On the previous steps, we added persistence and business logic to our microservice. Now we are ready to expose that functionality to external consumers. And in the industry, there are several popular protocols to call microservices. That includes HTTP REST and gRPC. It's not hard to implement those protocols using Pip.Services toolkit, but I want to show you even easier method. It uses a commendable pattern. Our controller component should return a command set, and a commendable service will automatically generate an external interface using that command set. Let's see how it's done. To implement commendable pattern, our controller must implement iCommandable interface. If on the previous step you commented this part of the code, now you get to uncomment it. The commendable pattern requires a single method getCommandSet, so our controller must return a set of commands that it supports. Then we need to add beacons command set class. Here we are going to construct our command set. Each command has a name, validation schema that uses to validate parameters from the requests, and then execution action. The action receives correlation ID and set of parameters. In the code of this function, we'll unpack those parameters, call our controller, and return the value outside of this function. So for the first command, we have getBeacons that receives filter parameters and paging parameters. Here we unpack those parameters, call getBeacons controller method, return the result. The second command is getBeacon by ID. It receives beacon ID as a string parameter. We call the business method on the controller and return the value. Similar way, we call getBeacon by UDI that receives UDI string parameter. Calculate position that receives site ID string parameter and UDIs as an array of strings. Create beacon that receives beacon as a parameter. Update beacon, beacon as a parameter. And delete beacon, beacon ID, string parameter. So now our controller implements commendable interface completely. Using this commendable interface, we can automatically generate an external interface, and that requires only 5 lines of code. So our external interfaces get to be versioned same way as we versioned our data objects. So let's create services folder and then version 1 folder under services. Then we will create class beacons HTTP service v1. So we add this v1 suffix to differentiate our service from other versions. And here the only few lines of code. We will inherit commendable HTTP service from Pip.Services toolkit, set the base path for v1/beacons, and then we get to define locator for our controller object. So we'll be using beacons controller, then any kind, any name, 1.0 version. So using this descriptor, our HTTP service will find controller, look if it implements commandable interface, get the command set, and uses that command set to generate external HTTP interface. For the tests, let's create services version 1 folder under test, place beacons HTTP service test class. Here we are going to create configuration parameters for our services. It will be using protocol HTTP. We'll run it on port 3000 and use localhost as a host. Then, similar to other tests, we'll create instance of persistence, memory persistence, configure it with empty parameters. We'll create instance of controller component, configure it with empty parameters. Then we'll create instance of HTTP service and configure it with our REST configuration parameters. And then to make calls to this service, we'll be using test commandable HTTP client from the Pip.Services toolkit, and we'll pass this v1 beacons as a base route. Then we will configure this client with the same REST configuration parameters that we used for our HTTP service. Then we need to assign references to those components. We'll create references at their memory persistence, controller, and service. Then we'll assign references to the controller so it can find persistence component, and we'll assign references to the service so it can find controller. Then we are going to open persistence, open the service, and open our test client. In the teardown, we'll close those components in the reverse order. will close client, service, and then our persistence. Test CRUD operations method will create two objects. This whole test is very similar to the controller test, only instead of calling controller directly, we'll be using our test client that calls HTTP service, and HTTP service will be calling controller. So in the call command, we'll call create beacon operation. This operation is the same as the name of the create beacon command in the command set, and we'll pass beacon as a parameter. The return object should match the beacon that we just created. Same way we'll create the second beacon. We will get beacons with empty filters, and we should receive exactly two beacons. We'll get the first beacon, change human readable label, call update operation, make sure that the beacon was updated. Then we'll get beacon by UDI, call calculate position, and in this case we'll be just calling only by the one UDI. So the position that we receive should match the position of the first beacon. Then we'll delete the beacon and make sure that when we get the beacon we receive an empty object. Now we can compile the code and run our tests. All tests executed successfully, including tests for our HTTP service. Now we have pretty much everything what we need in our microservice. We have a way to store and retrieve data from the database. We have implementation of the business logic and interface for external consumers. Now we need to have a way to put all these components together and run it as a system process. Let's do it at the next step.